we will continue with the volume of the some geometric regions, okay, and let me continue with the some spherical surface on the three-dimensional coordinate system, okay, and then let me give the example question. The region between curve y equals to square root of x for zero is less than or equal to x is less than or equal to 4, and the x-axis is revolved about the x-axis to generate a solid. Find its volume. First, the sketching this solid on the three-dimensional coordinate system, and the y equals to square root of x is this function, this graph, and when you revolve about the x-axis, okay, oops, it's not clear. Okay, and when you take the del of x from here, okay, and this part, for example, here will be x, and this part will be square root of x, okay, and which is also radius of the circle, and integral del v it equals to integral, okay, pi times, okay, y square, which is also square root of x square del x, okay, we know that, and the volume equals to integral from this point was 4, okay, and is from 0 to the 4, okay, pi times x del x, okay, so it's equal to pi times x square over 2, evolution bar from 0 to the 4, okay, and after that pi times, okay, and 16 over 2 minus 0 square over 2, it equals to 8 pi unit cube. Okay. And continue with another example. Find the volume of the solid generated by revolving the region bounded by y equals to square root of x and the lines y equals to 1 and x equals 4 about the line y equals 1. Okay, and this is important information. Okay, and please underline this part. Okay, and let me sketch it again. And this part this is y equals to square root of x again. Okay, and please look at it. Let me sketch the y equals to 1 line, which is here. Okay, and this is y equals to 1. Okay, and this part is maybe dot line or dash line. Okay, and after that x equals to 4, which is the x equals to 4 here. Okay, and after that, when you revolve this y equals to square root of x, okay, about the line y equals to 1, okay, you will obtain the like that. Surface solid. Okay, and maybe this part can be resketched again. Okay, and because of the center of this solid will be y equals to 1 line. Okay, and let me sketch it again. Okay, and this is realistic than the other drawing. Okay, and here is a part, which part is del x part. Okay, and we know that this is 4. This part is 1 again. Okay, and so volume element equals to volume of this solid, okay, and the del v equals to pi times, okay, and the now square root of x minus 1, okay, square del x, because of this line is here, y equals to 1, okay, and the so integral volume equals to integral from 1 to the 4, okay, and the pi times, okay, square root of x minus 1 square del x, okay, and then when you integrate this and put the values, boundary values, and you will find the 7 pi over 6 unit cube, okay. And then let's continue with the region revolved about the y-axis to generate any solid, okay, and the region between the curve x equals to 2 over y for and the y-axis is revolved about the y-axis to generate a solid. Find its volume. Okay, and this is y equals to 1 x and the y-axis, and our curve is 2 over y, okay, and at the 2 value, okay, x will be 1, okay, and so if y equals to 1, x will be 2, and so okay, and this point is 2, okay, and this is roughly a horn, okay, and okay, revolved, as you see, and this part is y equals to 2 over x, okay, and the green part, which is here, okay, this part is del y, okay, and the volume element, it equals to volume of disk, and the del V equals to pi times, okay, and the 2 over y square del y, and the volume equals to integral, okay, from 1 to the 4, which is the y values, don't forget it, and the pi times, okay, 2 over y square del y, and when you calculate this volume you will obtain the 3 pi unit cube, okay. And let me talk about the washer method, okay. Okay, and the if you have a circle or if you have a disk like that, okay, and this diameter is R1 and this is R2, and here is a height which is H, okay, and the washer's volume, okay, can be calculated by this formula, pi times, okay, R1 square minus pi times R2 square times H, okay, and the for example, let me show you a graphic about this washer method, and let's f of x is like that, okay, y equals to f of x, and the g of x is smaller than, okay, f of x on the whole interval, okay, which is defined, okay, and so I mean that, let me sketch it by the blue pen. This is the f of x, okay? I'm sorry, this is the g of x. This is smaller than the f of x. And when you revolve these two curve on the x-axis, okay, and you will obtain the I know that this is roughly sketching, but I'm sorry that there's some errors, okay, and this will be okay, and the black curves it will be like that, and this area wanted to be found the volume, okay, and what will it be? The washer's volume it equals to volume element, and the volume element can be shown by the only this part, okay, and there is a hole, okay, as you see, which can be illustrated by the blue g of x revolution area, okay, revolution volume, I'm sorry, and here is, okay, and maybe this diameter is R2, okay, you can assume that, and this diameter is R1, so easy to understand, and we know that the R1 is the g of x and the R2 is the f of x. So we can say the del V, which is the volume, equals to pi times, okay, and the square parenthesis f of x square minus g of x square, okay, and the del x. So it's equal to volume integral. For example, this part is A and this part is B, okay, and the volume integral from A to the B, okay, and the pi times, okay, f of x square minus g of x square, okay, del x, okay. And let me give you an example. What I mean, and then the region bounded by y equals to x square, and the y equals to 2x in the first quadrant, okay, is revolved about the y-axis to generate a solid okay, and find the volume, okay. Okay, and this is y equals to x square, okay. This is the y equals to 2x, okay, and in this part revolved about the y-axis, and that means you will obtain the okay, like that area, and here is the R1 or R2, I'm sorry, which is y over 2, okay, and the other one is square root of y, it is that second diameter, okay, and this part is R1, okay, and that means if y equals to x square, x equals to square root of y, so if y equals to 2x, x equals to y over 2, which are the diameter of the circles, okay, and the del v equals to pi times, okay, and the square root of y square, okay, which is the outer circle, okay, minus the inner one, which is the y over 2 square del y, and the integration, okay, v equals to, and this part also, and this part also will be from 0 to the 4 because of the this part is x square equals to 2x, okay, and the x times x minus 2 equals to 0, and this one is 0, and this part is 2, okay, and equals to integral from 0 to the 2, okay, and the pi times, okay, and the y minus y square over 4, okay, del y, and it equals to pi times, okay, y square over 2 minus y cube over 12, okay, from 0 to the 2, and the pi times 2 minus 8 over 12, okay, so it's equal to 4 pi over 3, okay, unit cube, okay. And now I want to continue with the volumes of the three-dimensional objects, okay, and which is also can be saying about the slicing methods, okay, in other slicing methods, okay, and they continue with the 7.2, that means And in this section, pyramids and conies are solids consisting of all points on the line segments that join the fixed point. We know that the vertex to all the points in a region lying in a plane, not containing the vertex. And we know that the region is called the base of the pyramid or coney. Some pyramids and conies can be sketched, okay, and by the like that, for example. Some of them are like that, and this part is, and some pyramids base can be triangular shape, okay, and some of bases, I'm sorry, this was not good, and they may be okay, and whatever. Some of them like that. Okay, this is a coney, as you know. Okay, and maybe arbitrary shape can be the base of any coney, like that. And as you see, all of these conies or pyramids, okay, have the edge heights, okay, and so all of them have base area like that, and we can find these volumes, okay, by the integral, okay, from a to the b, okay, and the a of x del x. And continue with the example, okay, and pyramid (3 meters high) has a square base that is 3 meters on a side. Find the volume of the pyramid. And that means, okay, and this part is 3 meters, and the height from the center of the square, okay, is 3 meter, h is 3 meter. So the one side of the, they talk about this on the coordinate system. Okay, what's that? Okay, and it's the triangular shape like that. Okay, and this part is 3 meters, and here is a disk del x. Okay, and this part is height. Okay, and the a of x equals to x squared, and the del v equals to, okay, and the a of x del x, we know that because of the area is of the circle is x squared, we know that, so it's equal to x squared del x. Okay, and the volume equals to integral from 0 to the 3, this point is 3 as you see, and the a of x del x, it equals to, okay, and the integral from 0 to the 3 x squared del x, so it's equal to 1 over 3 x cubed from 0 to the 3, okay, and which is equal to 9 meter cube. Okay, and that's the result of the square pyramid's volume.